All right, in this video, we are going to talk about the scope of variables, meaning where does a variable live within Java and how long does it exist? Let's get into what I mean. So, scopes of variables. The short answer to this is essentially that variables live within curly braces. Outside of a curly brace, they get garbage collected. Okay, what does this mean? So let's say, for example, that I have a while loop. And we'll use our friend from above, while x is greater than 0. If I create a new integer inside of here, and I set this new integer to, let's say, int x equals 15. Actually, let's go ahead and say -1. Okay. So int x equals -1. And then I can say system.out.println x. What do you think will happen here on our output? Pause and think about this for a moment. Which x will it use? Will it use the x that we have been using as an example for our while loops, or will it use this x right here? Well, the answer is that it is going to use this x right here when it prints. But the x here is still the x from the program, because as soon as this x hits the curly brace, it will be garbage collected. And what does that mean? Well, garbage collection is essentially freeing up memory. From unused stuff. Used variables, I'll say. So when Java sees that we get to the end of this curly brace, it will say, you don't need that x anymore because this x right here, the green x, lives inside of these curly braces. And because we're at the end of this curly brace, we don't need it anymore, so we're going to garbage collect it and free up that memory for something else that we might need later. And therefore, we get rid of this x. So any manipulation we do to this x inside of here will be lost. At the same time, because this x is the more local x, it's the closer x inside of the curly braces, Java will reference this x whenever it does any manipulation or change to x. So if you want to increment our x down like we did before, we do x minus minus here, we're not going to be able to manipulate the yellow x outside of these curly braces. There is a way around this, but we're not going to touch on that yet. So this is the scope of variables. A variable lives within the curly braces that it is declared in. So if we create a new x inside of our while loop, it's only going to exist inside of that while loop and only for each run. At the beginning of each run of the while loop, when we go back up to here, if this condition is still true, it will create a brand new x inside every single time. So if this runs 2 billion times, we will get 2 billion x's, but they will be garbage collected again at the end of each one of those runs. So be very careful about creating variables inside of loops because it can be very memory intensive and very CPU intensive as the garbage collector keeps coming up behind there, and you get all kinds of weird issues when you declare a variable inside of a loop. If you want to manipulate a variable inside of a loop, declare it outside and then manipulate it inside. Okay, let's talk about one other way to get out of a while loop. And that is our friend, the break statement. So we can put something like this. This is a slightly more complex algorithm for the while loop. So if we want to say, again, x greater than 0, and maybe we don't want this to run too many times. So maybe if x is greater than 0, we want to do some other kind of check on the inside of our loop, and then we break and get out of our loop. And that's the keyword we're going to use. So let's say, for an example, and I wouldn't really write it this way, but we could write it like this. If our x is greater than, let's say, 1 million. So we don't want this to run too many times. We can't put commas, but let's say 1 million. 3, 1, 2, 3. So if our x is greater than 1 million, then we're going to write our break statement. And it's a keyword break like this. And it will simply, the break statement will simply jump us out of the loop wherever we are and kick us to the end, and it will not reevaluate this. It will go to the end of the curly brace and immediately move us on in the code. It will not reevaluate. There is a more efficient way to use this, and we could use our Boolean logic to rewrite this, but there are some cases where you can't use the Boolean logic, and maybe you're making some manipulation. So the break statement allows us to get out of a loop without having to recheck our first condition. Okay, we'll move on to tracing these in the next video.